Significant figures. This lecture is meant to be a quick review of significant figures. So first, a little reminder of numbers that have zeros in them. They tend to be difficult to determine how many of the digits are significant. When you have a number with no decimal point, you start on the right side of the number and you begin to count significant digits with the first non-zero digit. So in 1,000 with no decimal point, there's only one sig fig. In 202, you have three sig figs. When a decimal point is present, start on the left side of the number, count with the first non-zero digit, and keep counting significant digits until you get to the end of the number. And I use the term significant digit or significant figure interchangeably. So here I have 2 sig figs. In 0.0045, start counting with the first non-zero digit. You have 2 sig figs. 1.01, start counting with the first one on the left of the decimal and keep counting till you run out of numbers. You have 3 significant figures. 4.500 times 10 to the second. You can ignore the power of 10, the magnitude of the number. You just want to look at the mantissa, and we have 1, 2, 3, 4 significant figures. A reminder about how to add and subtract when you are concerned with significant digits. So, when you're adding and subtracting, you don't look at the significant figures, but you look at the number of decimal places. So you're adding 4 plus 6, you all can add that to 10, but how many zeros do you put on it? None, 1, or 2. You look for actually the least number of decimal places, and so we have 1 decimal place in 4, so our answer should have 1 decimal place. With 10.0, it tells you that the uncertainty is 0.1, so it means you can go up 1, 10.1, or down 1 to 9.9 for your value. Subtracting, I have 15.00 minus 2. We all know that's 13. The number of decimal places determines how you express your answer. 15 has 2 decimal places. 2 has 3. You always go with the least number of decimal places for the digits that are involved in the calculation. And so our answer has 13.00 as its final answer, which means you have an uncertainty of 0.01. Multiplying and dividing with significant figures. Now you need to count how many significant digits are in your numbers. I have 2 times 2, but the first 2 has 2 decimal places, so 3 sig figs. The second 2 has 2 sig figs. Your answer can only be as accurate as the numbers involved, so you round to 2 significant figures. So 2 times 2 is 4, but we need 2 significant figures. Dividing follows the same rule. 16 divided by 4 is 4. You have 3 sig figs in 16, 4 sig figs in 4, and you need to round to 3 significant figures. Zeros are very important when you're recording a number. We have scales at our school that read to 1 gram. Your accuracy is plus or minus 1 gram. That's your uncertainty. We have scales that read to 1/10 of a gram. This has 2 sig figs, and its uncertainty is 1/10, plus or minus 0.1. When it reads to 100th, our uncertainty is 0.01, and we have 3 sig figs. So when you record your mass, you need to make sure you include those decimal places. When we have 1,000th of a gram uncertainty, your reading has 4 sig figs. So those zeros are very important when you're recording your numbers.